mathies, Gatos here. Welcome to this video in which we're going to talk about exponential functions and their limits. So let's talk about what an exponential function is. It's any kind of a function where x is the exponent. So for example, f of x equals b to the exponent of x. Now that exponent has to be a variable for it to be an exponential function. We are only going to deal with functions in which the base is greater than 0. So those are continuous functions. If the base was negative, we would have an oscillating function, and we won't deal with those in this video. Let's talk about the three different types of bases that we will deal with. First one is the base greater than 1. For example, 2 to the exponent of x. So let's talk about this graph and its domain and range. So the domain, I'm not dividing by 0, I'm not square rooting a negative, so there are no restrictions. So the domain is that x is an element of the reals. The range, if you look at this graph here, you'll see that everything is above the x-axis. So in other words, I can't have any value of x that would make that exponential function negative. So it's always going to be positive, and it will never truly reach 0. So you can see, for example, here in the table of values that I have, I'm already at x equal to negative 100. So 2 to the negative 100 is 0 with 30 zeros that follow the decimal, and then an 8. So really, really, really small number. We would essentially call it 0, but it's not exactly 0. So the range is the set of all y such that y is greater than 0. Now, because it can't truly ever equal 0, we have an asymptote at y equal to 0. Let's talk if it's increasing or decreasing. So to determine that, I need to read my graph from left to right. So as I read my graph from left to right, I can see that the graph is getting bigger. It is increasing. Let's talk about the limits. The limit as x approaches positive infinity. So as I have my x value, it gets bigger and bigger and bigger and bigger. You can see that it goes towards positive infinity. Let's look at the limit as x approaches negative infinity. So as x gets smaller and smaller and smaller, you can see it goes towards a y value of 0. Now the second case I want to look at is in between 0 and 1. For example, 1/2 to the exponent of x. So same thing with domain. There's no restrictions at all. I'm not dividing by 0 or square rooting a negative. When I talk about the range, you can see from the graph here and from the table of values, it will never truly reach 0. So the range is greater than 0 because there is an asymptote at 0. Now reading this graph from left to right, you can see that I'm getting smaller. So I'm actually decreasing. Let's talk about the limits. So as x gets bigger, so as x gets bigger and bigger and bigger, you can see that this graph goes towards 0. Or look at as x gets smaller. As x gets smaller and smaller and smaller and smaller, this graph moves towards positive infinity. So it's the exact reverse of what we saw in case number 1. Let's talk about my last case, which is just when the base is equal to 1. So 1 to the exponent of x. You'll notice in the table of values there and in the graph, y is always 1 regardless of what x is. So the domain, there's no limits. X is an element of the reals, but the range is that y is always equal to 1. Now let's read this graph from left to right, and you can see reading the graph from left to right, it is neither increasing or decreasing. It is neither. Okay, there is no asymptotes because the value of y is always just 1. Let's talk about the limits. So the limit as x approaches positive infinity, as it gets bigger and bigger and bigger here, you can see it's just approaching a y value of 1. And as x approaches negative infinity, you can see that that is approaching a y value of 1 as well. Okay, so let's use what we know about graphs to do some limit questions. So for example here, the limit as x approaches negative infinity of 3 to the exponent of x. Well, first thing that I notice is that the base is greater than 1. So since the base is greater than 1, I know that I have an increasing function. So when I have an increasing function, as x approaches negative infinity, this limit approaches a y value of 0. So by knowing my graphs, I could easily figure out what that limit is. Let's look at the other. the limit as x approaches positive infinity of 6 to the negative x. Now that's the first time we've seen a negative exponent, but we can easily rewrite that because we want our exponent to be positive as 6 to the negative 1 to the x, because negative 1 times x is negative x. That's really just the limit as x approaches infinity of 1 over 6 to the exponent of x. And now I can see I have a small base. My base is in between 0 and 1. So I know I have a decreasing graph, so something like that. And as x approaches positive infinity, you can see that this graph also goes towards 0. So knowing the graphs really pays off. Let's try these two questions. So if I have the limit as x approaches infinity of 10 to the exponent of 1 over x. So x is positive, but it's a reciprocal. So let's just think about this. 1 over infinity. So infinity is a really big number. And 1 over a big number is actually really a small number. So if we have 10 to the exponent of a really small number, well, that graph is going to go towards a value of 0. So here's my tip for you. As x approaches infinity, 1 over x approaches 0 because it's a really, really small number. And we know that 10 to the exponent of 0, not 0, sorry, 10 to the exponent of essentially 0 is equal to 1. So this limit has a y value of 1. Let's look on the next one. So the limit as x approaches 0 from the right of 5 to the 1 over x. So we're approaching 0. In other words, we're approaching a really small number. So 1 over a small number is actually equal to a big number. So my tip here is as x approaches 0, 1 over x approaches infinity. So this is like saying the limit as x approaches 0 from the right of 5 to a really big number. Well, if I have 5 to a really big number, that's going to approach positive infinity. So that limit would approach positive infinity. So you can see looking at these graphs either from a number perspective, these limits from either a number perspective or a graphing perspective will really help you out. So I have some textbook questions for you, and I hope this video helped, and I look forward to seeing you for the next one.